At the DRI, we work closely with researchers and cultural heritage professionals to preserve research data and collections. This means we know the challenges faced by those working with digital collections and data and safeguarding them for the future. So we were proud to sponsor the award for research and innovation. On behalf of the Digital Repository of Ireland, our members and the Irish community more widely, I'd like to congratulate all of those who were shortlisted in the category of research and innovation. This award acknowledges exceptional contributions to practical research and innovation activities that further the field of digital preservation. This was a very competitive field, and as one of the judges, I have to say that I am very excited to see the fantastic work that's being done in this field at the moment. One of the outstanding elements in this category was that each of the projects thought about sharing the outputs of their projects, whether that was methodology, a collection, a tool, or a service, to ensure that the full digital preservation community can learn from their work.
Hi, I'm Leo Konstantelos, Digital Archivist.
And I'm Emma Yan, Assistant Archivist in Archives and Special Collections at the University of Glasgow.
In this video, we will give you a quick summary of this work and why we use it as part of our digital archiving workflows at Archives and Special Collections.
We currently hold an estimated 300 terabytes of data deposited as computer storage media in our collections, ranging from floppy disks and optical media to hard disk drives and network storage.
To put it into perspective, it's the equivalent of 125 million digital photographs,
250,000 hours of video, 650,000 filing cabinets stuffed with paper records,
or 50 million copies of the Oxford English Dictionary, a stack 1,600 miles high, the same distance as Edinburgh to Athens.
So where do we begin with archiving digital records at such scale, with limited staff and resources? This is what we designed the storage media prioritisation methodology and tool for.
Whether it's an old cassette tape, a CD-ROM, or a modern external hard drive, the tool can quickly assess if a storage medium is at risk of data loss. We've collated resources and knowledge generated across the digital preservation community for all kinds of storage media and distilled it into 3 criteria that can inform prioritization: the year a medium was produced, its average lifespan, and its status in the DPC's global bit list of endangered digital species. We've added a 4th criterion, the conditions in which a medium has been kept, because it affects everything else.
So here's how it works. Simply choose media type and storage conditions, decide on the importance of each criterion in this case. The tool then generates a priority score and an imminence of action, which is based on the recommendations in the DPC's bit list.
The methodology and tool have been designed to be evidence-based, fully customizable to specific needs, scalable and extensible, so that it's easy to update with new data or revise knowledge about storage media longevity, and straightforward to integrate with existing workflows and other tools, such as digital assets registers. The tool is simple to use and portable in its current form as an Excel spreadsheet.
For institutions with computer storage media in their collections, our methodology and tool can help manage costs at scale through prioritisation, so that resources can be allocated where they matter most, and mitigate the risk of data loss by prioritising high-risk materials.
And it's also helpful for anyone wanting to preserve their personal digital collections. Got a box of old family photos on CDs and wonder whether you should do something about it? The tool can help you decide if they're at risk of data loss.
We've published both methodology and tool on the University of Glasgow's repository under a Creative Commons licence.
They're free to download and use, with all the necessary context and instructions to make best use of this work.
The first thing that I really just want to mention is, well, I guess it's just how interdisciplinary CHARM is. It integrates approaches and concepts not just from library and archival science and computer science, which our field is already fairly used to, but also design science and perhaps most innovatively risk science too. And because CHARM was constructed around the principles of design science, where utility is really key, it's not just logical and rigorous research, it's also really usable and it's practical as well. And I think that's really important for our applied field, especially when it comes to connecting our research and our theory with our day-to-day practice. And that takes me on to the second thing, the practical outputs of charm. And these were all produced specifically for a practitioner audience. There's several of them, including the charm reference model for digital preservation risk, but also a how-to guide with methods and templates for using the model, and a comprehensive glossary. Now, it's the reference model and its risk source concept that are at the heart of charm, and they're what I think make it so unique in our field. The main feature of charm is a digital preservation risk source model, and this essentially works as a holistic but institutionally agnostic map of the digital preservation risk source landscape. And its underlying structure comes from a risk source concept model that I developed that I think can actually be used across other domains as well to structure their own domain level risk source model. It's pretty neat from that perspective. And the final thing that I want to mention is the significance of the work and its contribution to our community. So charm was designed very much at the British Library for use at the British Library, but not exclusively so. It was developed for the wider field and for our community in general as well. The research in charm, it's empirically grounded, yes, but it's presented in institutionally agnostic terms, so it can be used in pretty much any digital preservation setting. Because the charm methods align with enterprise-level risk management practices, they can be integrated relatively easily with wider institutional management frameworks. And I think that's what really needed for digital preservation risk management to truly succeed. So that's charm. Its design is grounded in experience, in logic, in rigorous analysis and utility. It's academic, but it's also creative, it's innovative, and it's practical too.
Main aim of this project was to make recordings accessible, to digitize recordings that had been made by researchers, and then to build a community-facing resource. There was no agency taking responsibility for these recordings, so they were at risk of loss. We have a catalogue that currently represents over 1,360 languages in 230 terabytes, 16,600 hours of audio plus video, text and images, and we've moved everything to S3 storage in the last year. It's a project we did with Yap in Micronesia. You can see the tapes, and we digitized 120 tapes for them. We've also worked with the Solomon Islands National Museum and digitized many tapes, and you can see the tapes are sitting there and they're not being looked after. We go searching for tapes using our Lost and Found project, and we've, as a result, found a number of tape collections that we've been able to digitize. Now, we put everything into an online catalogue so that it's available, and this more recently, what's exciting is that we've been moving everything to linked data standards using Research Object Crate, and this is the exciting and innovative work that really changes the way that the collection is described. It's described internally. Each object has its own description, which means we can take arbitrary sets of objects out of the collection and create a catalogue for just those items. So this is an example of a viewer built on top of just RO Crate. This is not running out of our catalogue. And what this allows us to do is to search within items in the collection. We aren't able to do that at the moment because we search metadata, but not the items themselves. And as you can see on the right bottom there, where there is a transcript of a media file, it can be played together with that file, and we can search those transcripts. This is really exciting and innovative. It means that we can take small arbitrary sets of material, put them onto a Raspberry Pi, which is a low-powered web server, take this out into the field, and we've done this a number of times, and provide this information together with the catalogue of just that collection. So here's an example of people in Erekor village in Vanuatu looking at material from their language on their phones that's being transmitted from a Raspberry Pi in the environment around them. So we can take research recordings that were made in the past and were sitting in people's offices, and we can make them available for the source communities and be reused. It also means that the research that is done is grounded in the recordings that can be cited and reused. And we have lots of examples now of new research based on these recordings once they have licenses for reuse. This has all meant that we can collaborate with museums and archives in the Pacific that need help preserving analogue tape and have good ways of taking this back to them.
Hello, Melanie Swalwell, Play It Again project leader here. The second iteration of Play It Again focused on 50 games from the 1990s. It was very much a team effort. Here you're seeing some footage of myself and Cindy Moyer, digital archivist, in the Swinburne Digital Heritage Lab. We've had two main industry partners, ACME and ARNet.
Video games have been something that we've been collecting and working with here since we started in 2002 on this Federation Square site. And it's been one that, you know, I'm personally very interested in, and I think is a really useful field. Video games are really the preeminent media form of the 21st century, much in the way that perhaps film was of the 20th century.
We recognise the strategic importance of EASY, the emulation as a service infrastructure, to the benefit of Australia's GLAM sector and for artists and game developers as well. We also intend to operate the platform in Australia beyond the project term. It's been a really rewarding project to be a part of, to be immersed in the breadth of curatorial practice, to be a part of the community that's come about, and to see the fabulous works come back to life.
Well, King, you really know how to show a girl a good time.
Project outcomes have included the installation of 6 emulated vintage games in ACME's flagship exhibition, and here the reporter is demonstrating the ability for visitors to also play games emulated in EASY on their own devices. And here's the list of game titles that are available to play. Currently, these are only available to play on-site, owing to the exemption we are relying on in the Copyright Act. As I think we've demonstrated, the Copyright Act needs a rewrite.
New media forms are very difficult for institutions to dip a toe in the water of, and I think that sort of it's really important that national and state institutions, we're a state-funded museum, we are the safe place that needs to be taking these risks with new forms and new practices, and the discomfort that they necessitate. And the step into the emulation work has been really quite transformative for this organisation, but it's also proven to others that this is not something to be afraid of.
Perhaps most significantly, the Play It Again project has directly laid the foundations for the Australian Emulation Network.